Okay, so we're going to look at the AC frequency settings here next. So we're going to push the AC wave shape button a couple times to then pull up my preferred setting here, which is 150 hertz. That's what frequency is measured in. And now if you look, it'll go all the way down to 20, or on this machine as high as 400. So what we're going to do, just for demonstration's sake, is we're going to run at 400, we're going to run at 20, and we're going to run at my normal, which is 150. Again, this is just like pretty much everything else in welding, where it all comes down to operator preference and application, especially operator preference. So I have my number. You know, everybody has their own preference, but I'm trying to give you enough here to understand how this works to be able to figure out what works best for you, and then you can do with that what you will. So first demonstration, we're going to run all the way down to 20, and we're going to run at 20 hertz on a piece of 1/8 inch 6061, and we're going to show you what that looks like. Let's get it done. All right, so that is the far extreme, which is 20. And as you can see here, this band of the white frosty looking stuff is called cathodic etching. So this is a very, very soft arc, which means it's very wide. It flows very easily. And you can see here that this is a very wide bead profile at 20 hertz, and you're going to see that begin to narrow as we go next to 150, which I'm going to run next to this, and then I'm going to run 400 up here, where you can see that contrasted against the other two. It's going to continue to get a more focused and narrow arc as the number goes up, and again, that's frequency. It's read in hertz. So here we go. We're going to turn it up to 150, which again is where I spend the majority of my time on general application type jobs. 150 hertz, we're dialed in. Let's do it again. Okay, so as you can see here, going from 20 to 150, this bead profile is quite a bit narrower than this bead profile. Now, that makes a very big difference, especially when you're working in a T-joint, with how easy it is to get the two pieces to blend together. So you're going to find that the higher the frequency is, the more focused it wants to be on one of the two pieces. If you get a softer arc, more around that 150 level, it'll want to join the two together a little bit easier. And with aluminum, that's always a thing that is a little bit more difficult than on other materials like stainless and steel. So now what I'm going to do, and you're going to both hear the difference and see the difference, is I'm going to turn it up to 400 hertz. We're going to run it at the maximum setting for this machine, just to show you guys what that looks like. And again, I spend most of my time around that 150 setting, but it's pretty frequent that I'll go up to about 250 if I really need to get a focused arc. And so just for demonstration's sake, we're going to run all the way at the top at 400, and we'll show you what it looks like. Okay, so what you can see here is even the band of etching around the weld has narrowed up, the puddle has narrowed up, and you definitely hear the difference, which is quite substantial from especially 20 to 400, but even from 150 to 400, you can hear the difference in how the machine runs. And when you're holding the torch in your hand, you can feel the difference in how focused that arc is, where you have to really have the torch exactly where you want it to go, and that is going straight off of that tungsten in a very focused manner. So here again, depending on what you're doing, that frequency setting can really help you either make a very focused arc or a softer arc that is nice and wide. That's up to you and your application. Again, I spend my time around that 150 a lot, but I'll go up to 250, 300 even. And so with that being said, now you know how to utilize these settings a little bit. Get out there, go experiment and see what you like.